Hey guys, Mrs. Flanagan here. Today we are going to talk about arc length and sector area. This is the formula for the circumference of a circle. This is the formula for the area of a circle. When given this circle, the 8 centimeters right here, because it's halfway, starting at the center and then goes to the edge of the circle, that is our radius. So in this case, the r is 8. And so to find the circumference, we have 2 pi times the radius, which is 8, and then 2 times 8 is 16, and then the pi. When it asks for exact, we get the 16 pi. That's what exact means, is don't give us a decimal, just give us the answer with pi in the answer. And then approximate is when you type it into the calculator. And typing 16 pi into the calculator, it gives us 50.265, but it wants us to round to 2 decimal places. And so this becomes 50.27 for the approximate. And for the next example, notice the 20 goes all the way across the circle instead of just halfway. And so this 20 is the diameter, which then means for the radius, we cut that 20 in half and it gives us 10. So the radius is 10. The circumference then is 2 pi times 10. 2 times 10 is 20, and then we have that pi. So the exact circumference is 20 pi. The approximate, type 20 pi into your calculator, and it gives us 62.8318. But again, we want 2 decimals, so it's 62.83. For our next example, we want to find the circumference if the radius is 7. So we have the circumference is 2 pi r, but r is 7. And so exact, we multiply the 2 and the 7 together. That gives us 14 pi. And then approximate, type 14 pi into your calculator, and it gives us 43.98. And then let's go back and make sure we have the correct units on all of these. This was centimeters, so it's 16 pi centimeters, 50.27 centimeters. This was also centimeters, so 20 pi centimeters, 62.83 centimeters. Here, since there's no units given, what you would say is 14 pi units and 43.98 units. Now let's do some examples where we find area. For this circle, the radius is 10. So r is equal to 10. The area formula is pi r squared. And so we have pi, and then 10 is the radius squared. And 10 squared is 100. And so for the exact, we have 100 pi. Our units are feet. And for approximate, just type 100 pi into the calculator, and it gives us 314. We want 2 decimal places again, so it's 0.16, and this is feet, and then this is area, so it actually should be feet squared. Area is the unit squared. And for this example here, notice that the 14 goes all the way across the circle, but we just want radius again. And so half of 14 is 7. The radius is 7, which means area is pi times our radius squared. The radius squared, 7 squared, is 49. And so for the exact answer, we have 49 pi kilometers squared. And for the approximate, type 49 pi into your calculator, and it gives us 153.94 kilometers squared. For this example here, we want to find the area, but notice we were given the circumference. So we weren't given the radius, we were given the circumference. So we have to use the fact that the circumference is 2 pi r. We're told that the c is 14.9, so replace this c with the 14.9. And that equals 2 pi r. We want to find r, so we have to divide both sides by the 2 pi, right? R is being multiplied by 2 pi, so you undo multiplying by dividing. So divide both sides by 2 pi. And when you type 14.9 divided by 2 pi into your calculator, it gives us 2.37 for our radius. Now that we have our radius, we can use the area formula equals pi r squared. And this is pi, our radius is 2.37 squared. And typing that into our calculator, 2.37 squared is 5.62. So exact is 5.62 pi. And this doesn't give us units, so we would say it's units squared. And then for approximate, go ahead and type the 5.62 pi into your calculator, and it gives us 17.66 units squared. All right, let's go ahead and skip this entire next page. So I skip example 3A, 3B, and then let's go on to the next page. Now, instead of finding the circumference all the way around the entire circle, we want to find just a little bit, just a piece of that circumference. So this blue piece right here. Instead of saying circumference, we call this the arc length. We want to find the length of the arc. These are the formulas for arc length, depending if we are given radian for our angle or degree for our angle. It's important to remember that there's two different ways to measure angles. There's radians, which means if there's a pi in it, it most likely is a radian, and there's no degree symbol. And then it's a degree if there's no pi in it and it has a degree symbol. And then we're going to also talk about sector area. And that is just meaning instead of finding the area of the entire inside of our circle, we just want the area of a piece of the circle. And so it would be the area of this piece right here. And in this case, because our angle is 2 pi thirds, it has a pi in it, we know that's a radian measurement. So the radian formula for arc length is S equals theta times R. Remember, theta, right, is a Greek letter that mathematicians use to represent the angle measure. Oh, not greta, theta. Theta. And S then is equal to theta, which is 2 pi thirds, multiplied by the radius. The radius is 6. And let's do exact and approximate as well for these. So to find exact, what you're going to do is take that 2/3 and multiply it by 6, and then save the pi for the very end. And so 2/3 times by 6, that is 4, and then we have pi. So 4 pi, and then the inches is exact. And then approximate, you would type that into your calculator. And 4 pi approximate, so the decimal, is 12.57 inches. And now let's do sector area. So again, because we're given the 2 pi thirds, we know we have a radian, so we're going to use this pink formula for area. And the sector area is this pink area right here. That's what we are finding, the inside piece. And area is equal to 1/2 theta r squared. And theta in this case is 2 pi thirds. Our radius is 6, and that is being squared. So let's find exact. Exact is when we take the 1/2, multiply it by the 2/3, multiply it by the 6 squared, and then save the pi for the very end. And so typing all of this into your calculator, you end up getting 12, and then don't forget your pi. So for sector area, the exact is 12 pi, units is inches, and so it's squared since it's area. And 12 pi into the calculator gives us 37.70 inches squared. For this example, notice that the angle is in degrees. For arc length, then we want to use this green formula. So the arc length is equal to 2 pi r times our angle divided by 360. So 2 pi times by r, the radius is 2 feet, times by theta, that's our angle measurement, it's 300 degrees, divided by 360. So to find exact, you would take the 2, multiply it by the 2, multiply it by 300 over 360, and then save the pi until the very end. Typing this into your calculator gives us 10 thirds, and then we have the pi. So exact is 10 pi thirds, and we're using feet. And then approximate is when you type that into your calculator, and it gives us 10.47 feet. For sector area, this time we are going to use this purple formula since our angle is in degrees. And actually, let me highlight what we just found with this green. The arc length, right? The arc length is basically this piece right here. So it's like if you took a piece of string and you laid it around the circle and it only went that far around. It's asking what is the length of that string if it only went that far. And then for the sector area, you're finding the inside piece right here. That entire thing represents the sector area. And we're using this purple formula then since our angle is in degrees. So A is equal to pi r squared times by theta over 360. This is equal to pi. Our radius is 2. We're squaring that, and we're multiplying that by our theta, which is the angle of 300, divided by 360. So to find exact, we take our 2 and square it, multiply it by 300 over 360, and then save the pi until the very end. And typing that into our calculator, it gives us 10 pi thirds feet squared. And yeah, just so happens to have the exact same measurement as the arc length. And so the decimal for that, the approximate, is 10.47 feet squared. All right, what I want you to do now are examples part C and D on your own. Pay attention to if your angle is in radians or degrees. And go ahead and pause the video now. All right, here are all of the answers. And here's the work. Here are these answers. And here's the work. If you didn't get these, make sure you come chat with me about it next time in class. A couple of other things that I want to talk about before we finish these notes is the different notation here. This means it's exact. This squiggly line means it's approximate. And so go ahead and go back through and label all of the exact with equals and all of the approximate with the squiggle equals. There's a difference between those two different notations. And then the last thing is notice that when we were given the degree for our angle, the arc length ended up being the exact same as our circumference, right? 2 pi r, but we just multiplied it by the fraction of the circle we're talking about, right? We're not talking about the entire 360 degrees for our circumference. We're talking about just this piece of our circle, which ends up being 300 out of the 360 degrees. And then here, right, area is the same as what we did on the first page, the pi r squared, but we're doing a fraction of the area. So we're doing 300 out of the 360. So it's basically when your angle is a radian that it looks just a little bit different.